Not all sounds are the same. We can talk about different properties of sounds. We have different musical preferences and sometimes talk about good or bad music. For example, different instruments have different kinds of sound. So a violin sounds different from a recorder. A single instrument can produce a wide array of notes depending on the notes played on the instrument. Two people at different distances from a sound source will hear the same thing, but not with the same intensity. All these are properties that we use to characterize sounds. In this lesson, we will be learning about the property of sounds known as pitch. When you run your fingers through the keys on a keyboard, you will notice that the sounds you hear increasingly sound sharper to your hearing the further to the right you go. This is a characteristic of sounds known as the pitch. The pitch of a note is its position on a musical scale. It is what makes you differentiate a high note from a low note. It is also closely related to the frequency of the sound wave, though it is not exactly the frequency of the sound because pitch is a subjective property of sounds. Just note that the pitch of a sound increases as the frequency of its wave increases. Air that is vibrating more times per second will have a higher pitch, and air that is vibrating fewer times per second will have a lower pitch. Humans hear sounds best when the vibrations are between 20 Hz on the low end and 20,000 Hz on the high end. Sounds that are too low in the pitch for humans to hear are called infrasonic, while sounds that are too high for humans to hear are called ultrasonic. For example, dog whistles use ultrasonic pitches that are perfectly audible to dogs but too high for us to hear. Elephants, on the other hand, can perceive infrasonic sounds and use it to communicate over a distance of kilometers, while we can't hear these at all. They are also able to sense earthquakes, which are many kilometers away, without feeling any vibrations in their immediate vicinity. This is because earthquakes emit infrasonic sounds, which can travel far from their epicenter. You can test out the fact that pitch depends on frequency using different methods like the disc siren, a toothed wheel, or an oscilloscope. The disc siren is basically a circular metal plate with holes at regular intervals, with air blown through it. The faster you turn the plate, the higher the frequency of the sound that comes out of it. The frequency of the sound coming out of the disc siren is given by the product of the number of revolutions and the number of holes in the ring over which the air jet is placed, divided by the time of the revolution, measured in seconds. The toothed wheel operates in a similar manner. You simply rotate the wheel and hold a cardboard against the rotating wheel. As this wheel rotates faster and faster, the pitch of the emitted sound becomes higher and higher. The frequency of the emitted sound from the toothed wheel is given by the product of the number of revolutions and the number of teeth in the wheel divided by the time of the revolution. This is also measured in seconds. You can test this with a similar experiment at home. All you need is a comb and a pen. If you roll the pen across the comb slowly, it makes a deep sounding vibration. And when you increase the speed of your back and forth motion, the vibration is sharper. This shows that the pitch increases with the frequency of vibration of the teeth of the comb. So keep learning and check out our other lessons on the other properties of sound to understand more about how sounds are characterized. See you soon.